This
record the
conference will
session,
now
please
be
remember me.
recorded.
Okay, fine. So let me share my screen first. Okay, hope you're able to see my screen. You can respond, no? Okay, fine. Um, so the first and foremost thing, the moment if someone says learn SQL, or if the moment if someone asks you to learn SQL, what comes to your mind generally? Why I should learn SQL, right? Yeah, my senior suggested me to learn SQL when I was, completing my graduation and all. So first and foremost doubt I got is why I need to learn. Why not some other languages? Why not Python? Why not Java? And why not some other things? Maybe you heard this thing, right? SQL is a very easy language. It's just a query language which you can learn very simple, right? That answer is only 30% correct. 70% is depends on your brain. So Bhavya, do I need to sharp my brain? No need. What you need to do is you need to think. That's it. Think and do. That's it. Okay. So before understanding about SQL, first we need to talk about the data. So the moment I say data, what comes to your mind generally? Just give your definitions. Just give your definitions. Fine. Yes. If you're speaking, I'm unable to hear you. Perfect. Perfect. So some of you are, giving me the answers, collection of informations, right? Absolutely correct. Okay. So the moment I Google it now, it is giving me some definitions which I can't able to understand anything. The collection of facts and figures that are used for analysis, something like this. It is just giving me. So the main importantly, data is something like, something like collection of the information. So what is that information? See, information about any object is nothing but a data. Now, Bhavya, what is meant by object? Anything that have existence is nothing but an object. It's not on the earth, it's not on the universe, it's not on somewhere else. Okay, everywhere. It may be, planets. It may be out of the earth. It may be out of the universe. Anything that have existence is nothing but an object, and the information about that object is nothing but a data. Now, can we have some examples here? Now I'll give I mean I'll give some examples. You just tell me whether we can consider that as data or not. Okay, just give me yes or no. Now, um there is a laptop. Now, the laptop is in square and it has one camera on it. It has some keys on it, and it was, somehow, some height and width, something we have like that. So do you think all those information comes under a data? Color of a laptop and the features of a laptop, do you think all those things comes under a data? Correct. See, it's absolutely true. It's absolutely true that anything, it might be a color, it might be a countable, it might be an uncountable things, all those things comes under a data. Okay. Now, how many types of data we have? Only two types. One is qualitative and the next one is quantitative. Okay, so why I focused on the types of data means we must know what kind of data we are dealing. Okay, what kind of data we are just using, what kind of data we are somehow using for the analysis. Ultimately we are working with the data for what? For what analysis, right? See, let's say I have a company. Okay, I need to analyze the data, which means I need to analyze the employees that was working on my company, and the the products that are generating, or else the income that I'm getting. So all those things I need to consider, and end of the day I need to analyze whether I need to run the company the next year or not. So this is what the conclusion I need to take, right? Simple. Now, is qualitative data is going to help me, or else quantitative data is going to help me to do those analysis? So what is meant by qualitative data? Quality, right? So quality is nothing but which you can't measure. So measure in the sense which you can't count. So uncountable things are nothing but an qualitative data. So what is uncountable things? What are uncountable things? See, you are able to see the object, right? Now, can you measure and tell me, like, I mean, how many times you saw the object, or else not how many times, like you saw some object, right? Can you measure, like, how you saw that object or something like that? You can't measure the seeing, right? You can't measure your senses as well. So, the things which you can't measure or the things which you can't count are nothing but an qualitative data. Yeah, this is what we just understood, right? And qualitative data in nature, those are non-static, statistical things. See, statistical things are nothing but you're going to analyze, you're going to predict something based on the present condition. So that is nothing but in statistical data, right? And qualitative is no longer, or else no way, a statistical data, because if you smell something, you're unmeasurable. I mean, you can't measure the smell. If you taste something, you're unable to measure it. So those are nothing but a non-statistical thing. So if it is a non-statistical data, somehow you're not going to analyze anything. So these might be comes under the qualitative data and all. Yeah, you can take a cupboard as an example. So actually the same example you can consider in two ways, qualitative and in the quantitative. Okay, the color and it is made up of wood, and the smell of that desk, and the smooth finish or something like that are nothing but in qualitative data, like how quality it was made. Okay, the same thing we will take as an example for quantitative, and what comes for quantitative that we are going to see now. Yeah, quantitative means quantity, right? You're going to measure, somehow the name itself it is suggesting us, which you can count. Of course it is structured and the statistical one. So what is meant by structured, Bhavya? So that we are going to see in upcoming classes. Okay, tests, experiments, surveys, and market reports and matrix, all these comes under the quantitative data. Why all these comes under quantitative? Because you can somehow take, like, how many tests you have converted on particular product, how many experiment you have done on particular product in order to release into the market. So all these things, survey, the number of people participated in the survey. So all these comes under the quantitative one. And the same example, see, previously we talk about the color and the smell and the uh, you know something like that, right? Here we are just concentrating on the countable things. So fee, I mean, how tall of that one, weight of cupboard, like how many books we can store in it, how many cells we have on it, all those things, like what is the cost of that. So all those things comes under the quantitative data. Now my question is, which data is better for analysis? Which data? You can message me now.
Probably quantitative data.
Exactly. So without any doubt, it's a quantitative data. Okay, and the reasons you have here, I'll be sharing this PPT with you right after the class. You can go like why it is better for analysis or not. Okay, now, yes, you said quantitative data is best for analysis, right? Now, Bhavya, quantitative data is fine, but how we are going to do that? Or it's how the data is somehow there in the real time. Always remember, quantitative data will be in a structured format, semi structured format, or JSON files, all these things. But right now, SQL is something that you are going to learn only with the structured data. Only with the structured data. So, structured data means again a question mark, right? So, the things which are in the form of table is nothing but a structured data. It's just a simple definition. Okay, so before understanding about the structured data or before understanding about the all those things, we need to understand a relational database. Okay, SQL is somehow dealing with only the relational databases. Okay, so relational database means that was our next question, right? So we will try to answer this question. Okay, now, so can you answer this question for me, like how is data stored earlier? Yeah, any idea like how the data is somehow stored? Yeah. Like out of my knowledge, I knew that data is somehow stored in the form of papers. Okay, earlier it was on the leaves, but later on it moved to the papers, and after that text documents, and after that what? SQL. Okay, database. So finally, now we are going to store the data in the database. Okay. Now, um, like Bhavya, what are the disadvantages of storing the data on the leaves? What are the disadvantages of storing the data on top? I mean, on the papers or else on the text documents or all the on top of the Word documents. So, what are the disadvantages? So, you tell me, why do you feel like why we move to the databases, something like relational database or something like that? Why didn't we keep on using the only the textbooks, only the documents or something like that? Any idea? Okay, another example I'll give you. uh, let's say you have okay, previously, I think you remembered, we will be I mean teachers are going to take attendance in the book, right? So now everything is biometric. Now tell me, maintaining the attendance in the book is easy, or the maintaining the attendance through biometric is easy? Which is easy? Obviously
By
biometric, right?
biometric, yeah.
Exactly. So why it is so easy?
Easily accessible.
Yes, see, easily accessible, and one more, accessible is nothing but retrieving, right? Correct. And one more thing, let's say there is a student, okay, he doesn't come to the class, let us assume. So his friends used to give attendance for him as well. Okay, so whether he present in the class or not, whenever the teacher is maintaining the attendance in the form of register, so they used to tell, like he's present, he went here or somewhere. There, when it comes to biometric, he must be there. He must give its biometric to take the attendance. His friends cannot help in giving a biometric attendance, right? So how do you think the data is? Do you think the data is somehow corrupted? No,
No.
right? Yeah, because of these things, like there is a fast retrieval and the security of data. So keeping all these things in mind, we are now, not now, like from 10 years back onwards only, we are move into this. database concept. So Bhavya, do you think database will be somehow be in a place where the drawbacks of the data in a books or else the text documents going to be an advantage of the database? Yes. So whatever the drawbacks that you are going to see in the uh, textbooks or something like that, those are all the advantages here, then only we will be going into this database concept. Now Bhavya, what is this database? First you talk about the data, somehow it is clear now, then what is this database now? It is just a base for the data. Is that simple? Yes. See, you have a data and you must have some base to store the data, right? Yes, that databases, we have many things in the market, like we have many kinds of databases in the market. So out of all those databases, we are going to use only the relational database. So why we are going to use only relational database is our next question. So keep this question in your mind. In next 20 minutes you're going to get the answer for it. Okay. Now actually when I was researching on this database and all, I found an interesting question like this: what is database management system? So database is something like you need to have a base for the data, and to maintain that database we must have a management, right? Let's say you're organizing an event. Okay. Beautifully everything is very structured and very well planned, it is going, and end of the day you are getting some feedbacks that the function went very well or the event went very well. So how this is done very well, or else how this went very well? Back end you will be having the superheroes called management team, right? So here also when it comes to the database, for the database also we have a management system. So Bhavya, where we can see this management system? Can we go and buy in somewhere else? No, it is a software. Okay. So like let us assume tomorrow you become super scientist and you are ready to introduce one new database into the market. Make sure you must have, you must follow the management rules. Whatever the things you need to implement, or else whatever the things you need to introduce into the market, you must follow the management rules. Okay, like how the management team is working for the events or for the company or for the any other staff, the same here also. For the database, if we have a management system, then that is nothing but an DBMS. Okay, see, people started thinking more the moment I said DBMS. So nothing, it's just a simple, it's just a management system. It is going to manage your database, that's it. So how managers or else how management team is doing um, for the events, like it is they're organizing, this is the first event to be held and this is the next one and this is the third one, something like this, right? And everything should be organized one, make sure everyone should feel somehow free and something like that. Similarly here also DBMS will help us to maintain, have an organized data in a structured manner.
Hey,
And
Bhavya.
of course,
Hello.
yeah, yeah, Bhavya.
I, can I ask you a question?
Yes.
Yeah, so before actually knowing about the database management system, can I know the
Okay.
simple definition just for the database if you don't mind?
So for
Like in a
what?
general way, like what exactly is database in a general way? Like just like the way you're giving examples to everything, right? So I just want to
Yeah.
know what is database before knowing
Oh,
what is database management system if you don't mind.
okay. So
Yeah.
database is something like you need to maintain the data somewhere else, right? So let's
Yes.
say you're maintaining the data in the form of textbook, then that is nothing but a document.
Okay.
So you're going to maintain the data
Mm-hmm.
in a in a software or else in a, well designed thing. So
Okay.
that we call it as a database. It's a base in order to maintain a data. That's it.
So is it like a warehouse or something?
It's not warehouse. So warehouse is something different, like types of data we are going to have. So database, you know, just storing the data, that's it. Just storing, you're not
All
doing
right.
anything.
Okay,
Just
thank you.
simply
Thank you,
like
Nika.
whatever the data you have and you're keeping it
Mhm.
somewhere. You can
Okay,
take
thank
just
you.
like a locker.
Okay, got it. Yeah, thank you.
Fine. Good. Good question. um yeah, where we are. Yeah. So somehow, like how we are going to like how the management team help us in the event, similarly here also our management system will help us, the users, to do all those things. Like if you want to create something, if you want to modify, if you want to query, all those things. See, database, somehow you can make it as a locker or something like that. You're going to keep your data inside it and you're going to lock with your security key and password, that's it. So fine. Now, what is DBMS? So, like you said, database management system, that it is going to, manage the database. That is fine. But what is the advantage of having this database management system, right? Like, you can take any database. So, it is going to manage everything. But why? Why it actually needed? Why management is actually needed? So we have discussed many things right so far, right? So now let us see, like, is this really going to work or not? Advantages of DBMS. See, first thing we talk about the control database redundancy. So redundancy means, I'll try to explain you this word with an example. See, make sure guys, you need to habituate, the terminology. Okay, more than understanding a concept, you need to understand the terminology. That is very important. Okay, now I'll just give you an example in order to understand what is meant by redundancy. Let's say you have a data in your textbook, not textbook, in a notebook, like you're maintaining each and every person details in a notebook. Okay, so in the early morning you have returned a person details, and the same person has came in the evening session, and you want to maintain a record of that person. Okay, so time, there is no change in the data. Okay, there is no change in his details. Okay, the same data you are repeating. The same thing, if you maintain in the database, somehow you can control the redundancy. So first name of that person repeated after the 100th name. Okay, after 100 people he got repeated. So for you it will take almost 10 minutes of time to identify that this person has came, or else this record got duplicated. Obviously it will take, right? But when the same data was present in the database, in just a fraction of seconds you can say that this record got duplicated. So duplicated is nothing but an repeated. So this, in terms of SQL, we call it as an redundancy. So redundancy we can somehow control. I'm not talking about you can prevent it, you can control it. There is a difference, understand? Okay, so it's quite common to get the duplicated records, but ultimately whether you're controlling it or not is your turn. So that you can do by using a DBMS. Next one, obviously privacy will be there. Like if you want to enter into my database, you must have my credentials, you must have the username and password to look into my data. So when it comes to book, keep book inside the room and lock your door. Maybe some people from the window they'll enter into the room and they can corrupt your data. So if it is in a laptop, they must destroy the laptop, that's it, until unless they'll not get anything. Next one, data integrity. So integrity means what? In general, in normal English, honesty, right? Honesty of the data, right? So let's say today my salary is 2000, and this record that my HR team mentioned in a notebook, and they were making sure no one should enter into that safe room and maintaining that record. Okay, but the person who don't like me has entered into the room and somehow erased my data and changed my details. Okay, then later on people don't know, right? So this is the case, like it got erased or it got changed, people don't know that. Honesty is missing. The salary is 2000 and the email id is this one, phone number is this one, or else the problem or the thing is this one. There is changes in that, honesty is missing. But when it comes to dbms, this management system is giving a surety that your data is honesty if you maintain a database. That assurance it is giving us, that integrity will be there, because they must need a credential if they want to corrupt some data. If they do that, if you feel like there is a corruption, then you can simply question them, right? You got the credential and this is what you have done. So that honesty, that integrity will be there if you have a dbms, if you maintain a database. Yes, obviously backup and recovery nowadays, previously everything will be in the system. So what happens if you have a natural calamities, what happens if someone destroys the laptop, maybe the data will be lost. Somehow that fear will be there in our minds. But now everything is in cloud, everything is in cloud. So that security also we have. But right now we are going to discuss only the on-premise one. So I'll tell you what is meant by on-premise and cloud. No worries. So somehow here also you can take a backup and recovery. I mean, this database DBMS is giving that assurance. Yeah, sharing of a data, like if you have a data, you can import it, you can share with some other people, and the data consistency also will be there. So consistency means what? Let's say you have 100 rupees in your account and you've withdrawn 50 rupees. Okay, now the consistency means out of 100, if you remove 50 and the next one is 50, right? So balance should be there. Before and after withdrawing, the amount should be same. See, I'm not talking about after withdrawing also your account should show only 100 rupees. No, it's not a consistency, it's somehow a mistake. Okay, after withdrawing there should be a 50 and in your hand it might be a 50. So that consistency should be there before and after the transactions. So that is nothing but a data consistency. Obviously security will be there, because as we talk about the privacy, we will be entering into the database with the credentials, so obviously security. So these are the advantages that we have for dbms. So if someone says I have introduced a database now. See, database means it's something like you'll be having many databases. Okay, tomorrow you become a scientist and you're trying to introduce a database into the market. Make sure all those things need to be satisfied. Your database should satisfy all those things, then only you are good to go, otherwise no. Okay, so the next one, very important one, acid properties in dbms. Okay, so what is meant by acid properties? You might learn about this one in your college, right? Atomicity, consistency, isolation, and durability. So Bhavya, how acid properties and dbms are linked? Simple. These are the properties that every database must have to satisfy. Okay, it might be a new, it might be an old one, or it might be a coming one. So anything, any database need to satisfy these acid properties, and these things you can see in the dbms. Management system will somehow give rules and properties, right? So these acid properties are we will be seeing in the dbms. So what are exactly mean by acid? A stands for atomicity, C stands for consistency, I stands for isolation, D stands for durability. And please make like if you're maintaining a notes or if you're maintaining a document right now, make star, keep 10 stars over there, because even if you're experienced or not, people are going to ask a question on this. From fresher to the experienced one, you will be expecting a question from the acid properties. Why? I'll tell you why. See, atomicity. First and foremost, atomicity is nothing but what? See, I'll try to explain these acid properties with ATM example. Okay, I'll try to take ATM as an example and I'll try to inject this thing in your mind. Now, you have an ATM. Generally, we will be having an ATM card with us, right? Like we need to have some transactions, like you need to withdraw some amount. So I mean, every time you will not go to the bank to get the money, right? Now, you inserted a card into the ATM, either you will get the money or else oops message. Only two things has to happen. So do you think two things will happen at a time? You'll get a message and you will get oops message. See, oops message is something like your transaction got cancelled. Keep this in your mind. Okay, oops is something like mistaken. Two things will never happen at a time. Similarly, atomicity also the same. Either the transaction of withdrawing money has to complete, or else the transaction should declined completely. Any of that need to happen. Two things will not happen at a time. See, that is what the definition itself was also telling. The entire transaction plays at once or doesn't happen at all. Either it should happen or it doesn't happen. Only one thing need to do. That is nothing but an atomicity. Now, Bhavya, how it is related to our database or how it is related to our data? You're inserting few records into your table. Let us assume you are entering one person details into the table. Either you need to enter that record or else you need to get out of that record. Only these two things has to happen. No clash between two records should happen. You need to make sure if you are developing a database, this atomicity is very important. The next one, consistency. So consistency is nothing but like before and after the transaction. So let's say you inserted the card and you get some amount. So before withdrawing the amount, you have 1,000 rupees in your account. After withdrawing 500 rupees, now it's only 500. Now you check the balance, it was somehow clear, and you will be with a piece, you will get out of this ATM machine. If it is showing only 10 rupees after withdrawing 500 from the 1,000 rupees, somehow you will get panic and you will go call to the bank account. That's a different story, right? Here also the same. Consistency. You deleted one record from a table. Let us assume you removed, okay, in normal terminology I'm just telling you, you removed one person details from a table. Before it was 10 person details. Maybe you're not getting if I say records. Okay, records is a SQL terminology. I'll tell you what does it mean. So you have 10% details in your table and you removed 1% details. Now how many you will be having? Nine details, right? I mean 9 persons details, right? So that is a consistency. If you remove 1% details, if you are getting only 8 people's details, then that is not a correct data and that is not somehow working correctly. So that consistency must be there. So C stands for consistency. And the next one, isolation. Isolation means the same. I am withdrawing 100 rupees from the ATM. At the same time, I am transferring 200 rupees through phone pay. I'm or else my mother is using somehow net banking to transfer some amount. See, all these transactions are doing for only for one account. And what my mother is doing, that should not affect my transaction. What I'm withdrawing from the ATM, that should not affect my online transaction or else a phone pay transaction, right? So that is nothing but an isolation. So independently every transaction need to be work. That is the next property. You heard this thing in COVID times, right? Isolation. So what is meant by isolation? You are let's say the people who affected with the COVID, you are isolating that person, you are somehow keeping that person from the group, away from the group, or you are giving a room to that person and make that person to sit, somewhere where people will not roam, right? So just simple like that. Every transaction should occur independently. One should not interfere in another things. Similarly, if you are inserting few records, I mean, if you are entering one person details into the table, next person details should not affect, or else two people parallelly entering the details into the table, those two should not clash. Okay, obviously in the database there is a technique. If you are inserting, first insertion will happen, after that only updation will happen, so no two commands will clubs. Okay, those any command if you run, there is no chance of merging or something like that. Okay, now the next one is durability. So durability is nothing but if ATM fails, okay, let us assume you inserted a card and unexpectedly some natural calamity or because of the man-made mistake it got blast. Okay, so don't get any panic. What happened? So you didn't made any transaction, or else even though if you made, if the money is not out, there is a chance, there is almost 100% of chance that you will be getting help from the bank, that your transaction is failed, or else this is the thing that was happened, yeah, we are going to help you with that. Similarly with the database also, if the transaction is successful, it is going to store. If it is in between and the system got failed and it is not somehow entered into the table, still you have the data with you. So even the system fails, you will be having data with you, some backup and recovery you can get it, right? So that you need to somehow contact to the support team, those all belong to the admin department. Okay, no need to think much about it, but make sure even if the system fails, your transaction will be somehow safe. That is nothing but a durability, security, all this comes under the durability. Okay, so these are the properties, these are the acid properties that we are going to have in the database management system. So Bhavya, are we going to work on these properties now? No. So I'm telling you, right, these are all not the queries. Okay, these are all the properties. While introducing some database, or else while introducing something, let's say we have a database management system, right? That management system itself was having these properties. Tomorrow if I want to insert some, I mean tomorrow if I want to introduce something to the market, I must follow the acid properties. Okay, tomorrow I'll become a scientist and I'll be introducing, yeah, I have introduced a beautiful database, so please go and use. If I say something like this, why people should use it? They need to test, right? Whether it is a database or not, before publishing it they need to test whether it is following all the properties, all the rules and or not. So those things are nothing but an acid properties. Okay, so any doubts in acid property? Anything you want to clear about it?
Bhavya, can I have a ATM example once again for isolation, please?
Isolation?
Yes, please.
Okay. Isolation is something like uh, like multiple things was happening at a time. Okay, let's say you're entering few details, updating few details, but in the database there will be a separate storage or separate place for each and every activity. So if you are entering the details, so until unless that record got entered into the table, there is no interruption for the next record, there is no interruption if you are updating the next one. Okay, for each and every transaction there independently it is going to occur.
So let's say if I'm making a change for a record, it doesn't affect on the other record, which is the other
No.
line, other
Yeah,
details.
exactly.
Okay, thank you.
Yeah. So practically we can't do it actually. Okay, so why? Because these are the properties, right? So you can't execute something, you can't do it something on the properties. Okay, so those are the properties that have set the mark that you need to follow all those things. Okay, fine.
Okay, Bhavya,
Apart
thank
from
you.
this, yeah, so apart from this, do you have any doubts on this acid properties? Yeah, so go through it again and come back to me, no worries. Okay, I'm here to help you out. Go through the concept again and come back. Now, let's see this types of database management system. We have more 7 minutes, so we can complete this one. So actually we have all those things: hierarchical, networkal, relational, and object oriented. All those things we have. So right now we are using relational model. Okay, why we are using relational model, that I'll tell you now. Before that, let us understand this hierarchical one. So hierarchical database management is something like you are going to maintain the levels here. So let's say vehicle. So you have two wheeler and the four wheeler. So in the two wheeler you have two different things. In the four wheeler you have many different things. So let's say you have car, you have many brands. Let's say you have bike, you have many brands in that. So that is nothing but an hierarchy. You're going to maintain the hierarchy. So previously in 1960s or in 1950s, people are having this hierarchical database management system. Okay, so somehow they're going to maintain the data in a hierarchy, in a level format. Okay, so what is the drawback of this one? See, if something has a drawback, then only the new thing comes into the picture, right? In general, let's say A has a drawback, that is why B comes into the picture with the by making the drawback as an advantage, right? So the drawback of this one is, if I want to get the details of a SUV cars, so what I need to do is I need to enter into, I need to go to the vehicle one, and I need to go to the four wheeler, and I need to get the car, and I need to get in the SUVs, and then I'm going to get the detail. Now I don't have I have only the details of this one. I don't want to enter the details of these particular what I can say, these particular I don't want to enter any data to this particular data, tables. Let's say vehicles table, four wheeler table, or car tables. So I have only the information related to SUVs. I can't enter just like that. I must follow the hierarchy. I must follow that. So every time it is not possible, right? Every time entering all the details related to vehicle, four wheeler, car, and SUVs, all there will be a chance of redundancy. So huge redundancy. Okay, so let's say four new things was happening with the SUVs, and four times the car repeated, four times four wheeler repeated, four times vehicle repeated because of hierarchy. So huge redundancy. So Bhavya, what happens if you have a redundancy? It will take some time, right? So if I ask you to count the 10 numbers, count the numbers from 1 to 10, so what you will do? In a minute you will just count it. If I ask you to count the numbers from 1 to 20, it will take some time. If I ask you to count the numbers from 1 to 100, it will take some time. So whenever the numbers are increasing, the time is also increasing, right? Similarly here also, if the uh, i mean values, if the records are increasing, the execution time may increase. And previously somehow good, we have a little amount of data, limited amount of data. But right now, if I get a time, we'll open an Amazon in order to do shopping, right? So that you're giving your data, man. You're giving it to the Amazon people. You're scrolling it, and you're somehow adding something into your cart. You're ordering something, you're canceling something. So that is nothing but an data for them. So that much huge data, hierarchical database will never handle. For one simple thing only, it is maintaining 4 n number of records, then what about the data now? It's somehow thinkable, right? So because of that execution time and the hierarchical database got failed. It got failed. So failed means somehow there is no loss. Somehow people felt that okay, it is not going to work anymore. So let's move on the next one. So after this hierarchical data, we have something called networkal database management system. In 1970s or mid of 1960s, the networkal came into the picture. So how it is going to work? Whatever you take, I mean, if you take department 10, if you take department 1, if you take department 10, if you take a college as an example, somehow you are considering the departments. So if you want to get the people, those who I mean, the number of students that we have in the department, you can get it from the college, you can get it from the director. Okay, maybe somehow related, right? Or else teachers that are working in particular department, from teachers to the heads are reporting to director, something like this. Again, the hierarchy got reduced but the connection was there. If I want to have a data for the department, I must have a data in the college, or else I must have a data in the director table. Anything is fine. Yeah, it's true that hierarchy got reduced, and it's true that somehow the duplicates got reduced, but the problem is you need to maintain the two tables, right? If you have a data in the department table, you must have a data, must maintain the thing in the college table, or else you must maintain the thing in the director table, right? Again, a big question mark. Again, it will give somehow execution error. Because see, some up to some extent, you know what happened, networkal database management system has ruled, okay, till early of 20th century or somewhere around like that. It got I mean, it was in the market, but because of as we know that daily the data was increasing, daily a new records, daily a new amount of data, daily a new issues. Because of that, networkal data was is also somehow become very slow. When the data is increasing, execution will decrease, right? It's just a transposal thing. So when the work is increasing, you'll somehow your energy decreases. As simple as that. When the number of records are increasing, the execution, the performance of the database management system is also decreased, the networkal one. After that only the relational database management system came into the picture. Okay, that we will see. But before that, we have something called object oriented one. So object oriented is nothing but you will take one object and you will be have, I mean, you will be maintaining some data related to that object. So these all, I mean, this object oriented data you will be seeing in the programming languages. Let's say you have Java, Python or something, so you must write a code in Java to maintain a data related to any object. Okay, so that this one was right now we have this object oriented database management system in the market, but the people who are using Java and all, they are doing it, but that is also not that feasible. Okay, it is not that it will not handle huge amount of data. You can't write a code for a huge amount of data, right? So somehow because of all those things, we have something called relational database management system. From the decade, this relational database management system is ruling the world. I'm not talking about India, I'm not talking about US, I'm not talking about anything. Throughout world, this relational database only ruling. Why, Bhavya? Why only this one? Because it was maintaining the data in the form of table, and to have that relational database management system, it has some rules also. Actually, this relational database management system was introduced by EF Cod. Okay, so Cod has some rules if you want to maintain a database in the relational model. So you must follow that rules. So that rules we will be seeing in the tomorrow's session. Okay, but remember, relational data is nothing but in structured data. So relational, structured, both are same, which is nothing but a table format. So how you are going to relate? I mean, Bhavya, like how the data is stored. Let's say employee and department, how these are stored. You will be maintaining two different tables. If required, you will join those tables. You will establish a relationship between those tables. Otherwise, no. If it is required, then you will establish a relationship. Otherwise, no. No performance, no duplicates, nothing. See, I'm not telling you that you will not have any duplicates, but I'm telling you that even if you there is a chance of reducing the duplicates. Instead of having 10 duplicates, if you maintain a relational model, you will be reduce it to 2 or 3, that's it. And you the querying is somehow very faster. So that is why the relational model is ruling the world now. Okay, the next question is the same. What it is, which DBMS is leading? Now, the next one is very important one. SQL is used to communicate with the relational database. Okay, we saw about the data, we saw about the database, we saw about the management that was maintaining database, and finally we come to the conclusion that relational database we are using. So can you, can you answer me this question, like what kind of data we have in the relational model? What kind of data we have?
Is it structured and organized data?
Exactly. It is structured and organized one, which is nothing but quantitative data. So if someone asks you like what kind of data you are maintaining, so don't tell me it's a table format, or don't tell them that we are maintaining a structured one. Tell them that it's a quantitative and the structured data. So why? So quantitative, it is in the like countable one and the statistical one, and the structured means somehow in the table format. So in just two words, the definition was covered. And somehow if you want to talk to the database, if you want to communicate with the data relational database one, we have only one language, that is nothing but an SQL. So in tomorrow's session we are going to learn about the what is SQL. Okay, so how why actually SQL comes into the picture. So can we communicate SQL with some other things? Can I use SQL to get the data from the documents? So all these questions we are going to see in the tomorrow's session. Okay, so that's all from my end for today. Do you have any doubts? Please feel free. Yeah. People who are having the doubts can stay, and rest of the people can leave. Yeah. Thank you guys. Thanks for your time. Have a great day.
Thank you, Bhavya. It was a great class, the first one. And can I find these PPTs in the group,
Yeah.
the
I'll share it.
presentation?
Yeah, I'll
All
share
right.
it.
Thank you. That's the only thing.
Yeah.
Thank you. See you tomorrow.
Yeah. Thank you. Yeah. Thank you guys. If no doubts, you can wind up the session.